Alright guys, so here we've got a mixed circuit. We have resistor 1 and 2 in parallel, and those are in series with resistor 3. When you're doing a mixed circuit, first thing you want to do is find the resistance of this parallel part of the circuit. And you're going to do that using the 1 over rule that I like to call it. We're going to say that 1 over the parallel resistance equals 1 over the first one plus 1 over the second one. So 1/2 plus 1/6. 1/2 plus 1/6 is that'd be 4 over 6, which would end up being 2 over 3, right? 2/3. But we know that's not the parallel resistance, that's the inverse of it. So the resistance of this parallel part of the circuit, which I'm going to write down up here as RP, is 3 over 2 ohms. This is 3 over 2. From here on out, at least for a while, I'm going to think of this whole circled section as what? As one resistor with a resistance of 3/2 hooked up how with that other 3 ohm resistor in series. Keeping that in mind, if I want to find the total current, and I'm thinking of this like a series resistor now, series circuit, 3 plus 3/2. Well, that's going to be what? This is 6/2 and 3/2, add them up, 9/2. To find the total current, I equals V divided by R. So let's take V6 divided by R, 9/2. Now if you do a little invert and multiply action there, you end up like so. So you end up with 4/3. 4/3 of an amp. That's the total current. Now I like to go ahead and drop down now and think about the easy resistor to deal with. This is the easy resistor to deal with. Because what has to go through that resistor? Everything. That's the only way back to the battery. So the current through there has to be the same as the total current. 4/3. So that's I3. 4/3 of an amp. Let's go ahead and find the voltage of this resistor. To find the voltage, we need to go what? What do we need to do? I times R. So 4/3 times 3. That's just 4, right? 4/3 times 3. I times R. So the voltage at resistor number 3, 4 volts. Now we've got to go back and work on this parallel part of the circuit. First of all, again, we're going to think of this like one series resistor. If the voltage of this resistor right here is 4, what's the voltage of this whole thing have to be? Nope. Oh, somebody said it. Somebody said it over here. It's got to be 2. Because we know that if we're thinking of this as one resistor, this voltage plus this voltage has to equal the battery voltage. 6-volt battery. So, Matt, you asked what? V equals IR. So, the resistance here is 3. The current here was 4/3. 4/3 times 3. Right, but again, another way to figure out this voltage, all the current has to go through this circled section one way or another, right? Think of this as one resistor with this much current and this much resistance. If we know the current and the resistance, how do we find the voltage? We multiply it. 4/3 times 3/2. That's going to give us what? 2. It's going to give us 2. The voltage of this whole thing is 2. Now here's the key step. If we find the voltage of the parallel part of the circuit to be 2, what does that mean about everywhere in the parallel circuit? Each branch at least. It's 2. There's only one resistor on each branch, so that should tell you that V1 is 2 volts and V2 is 2 volts. Voltage is constant across each branch in a parallel circuit. And all that leaves us with are the I's. At resistor number 1, to find I equals V2 divided by R2. So we get 1 amp. V over R. At resistor 2, V, 2 volts, divided by R, 6 ohms, we get 1/3. Always check that. These two currents should add together to be what? The total current. 3/3 plus 1/3 is 4/3. That's it. I'm going to pause this for a second. Just 1 second. Pause it. All right, guys. Here we have a mixed circuit, but there's one thing that complicates what we just saw a minute ago. Here, well, in the previous example, we had only one resistor on each branch of the parallel part of the circuit. Here we got more than one, at least on one of those branches. So, the most important rule for working this problem. If you listen to this and you do this first, it's not much different than the last problem. When you're dealing with complicated mixed circuit problems, like we're dealing with here, the first thing you want to do is find the resistance of each branch of the parallel part of the circuit. Well, obviously, this branch is just 3 ohms. What's the resistance of this branch of the circuit? 3 ohms, because how are these two hooked together to each other? They're in series. To find the resistance of this branch, you just add 2 and 1 to get 3. So for right now, we can think of this as one branch with a 3 ohm resistor, and this is another branch with a 3 ohm resistor.
Wait, so you're not doing it one time?
Yeah, I'm about to. First of all, we're going to find the resistance of each branch. Then we're going to do that. That's next. All we did right now is we add up everything on this branch. We add up everything on this branch. That's it. Now we've got to do what was our first step in the last problem. And our first step in the last problem was to first find the resistance of what? The parallel part of the circuit. So we're going to find the resistance of this whole part of the circuit right now. And to do that, 1 over the parallel part of the resistance is equal to, here's a different part. Here we're not breaking it down by resistor, we're breaking it down by what? By branch. So it's going to be 1 over 3 on this branch, 1 over 3 on that branch. So that's 2 over 3. And we know that's not the parallel resistance, that's the inverse of it. So the parallel resistance is 3/2. From here on out, the problem's going to work pretty much just like the rest of them. So what we did first, we found the branch resistance by just adding up the resistances of each resistor on the branch. Then we used our normal parallel resistance rule to find the total parallel resistance. What's the next step? Think of this whole parallel part as one resistor with a resistance of 3/2 of an ohm hooked up how with this other resistor? In series. So 3/2 plus 2 is what? 7/2. Our total resistance is 7/2 of an ohm. Now we want to find the current. To find the current, I equals V over R. Battery voltage, 6 volts. Divided by circuit resistance, 7/2. Invert and multiply. 2/7 times 6 over 1, 12 over 7, right? Our total current is 12 over 7. That's 12 over 7 amps. Now, it doesn't really matter the order you do this, but I always like to do this one over here because this is the easy one. All the current has to go through that, right? Because it's in series. So I4 is going to be 12 over 7. And to find the voltage at number 4, V equals I times R, Ohm's law. So at resistor 4, 12/7 times 2, 24 over 7, right? That's the voltage. Now, here's where it's maybe slightly more complicated than what we did in the last problem. We're thinking of this whole circled green part of the circuit as one resistor with 3/2 ohm resistance. How much current goes through that whole thing? How much current goes through this whole thing? Hold up. All of it's got to go through here, right? All of it, 12/7. So if we think of this as one resistor, it's got this much resistance and that much current, okay? Which means to find the voltage of it, I times R, which is going to be 12/7 times 3/2. And if we do the math on that, that comes out to be 18/7. That's the voltage of this whole thing, which is also the voltage of what?
Each of them.
Not each of them, but each what? Each branch. That's the branch voltages. Now here's the thing. This branch only has one resistor on it, right? So the voltage of resistor number 3 is what? 18/7. But the other branch is a little bit different because it's got 2 resistors on it, right? What if these 2 voltages, number 1 and number 2, have to add up to be 18/7? We'll come back to that in a minute. Before we do that, let's go ahead and finish up number 3. We know the voltage at number 3 was 18/7. We know the resistance at number 3 is 3. So to find the current at number 3, we're going to go I equals V 18/7 divided by R 3. We're going to get what? What's 18/7 divided by 3? 6/7, right? Now, here's the easy way to do the other part. All the current comes to right here, right? Leaves the battery, gets to right here. That's 12/7. 12/7 get right here. 6/7 go this way. Which means how much goes this way? 6/7. Everybody with me on that? 12/7 come out of the battery, they get to right there. 6/7 go this way. That means the other 6/7 have to go that way. These two are in series. What do we know about the current in a series part of a circuit? It's the same. So if 6/7 go this way, they go through here, and they continue until they go through there, right? So that tells us that I1 and I2 are both 6/7 7 So how do we find the voltages for 1 and 2? I times R. So at number 1, the resistance is 1, the current is 6/7, so I times R would be 6/7. And at number 2, the current is 6/7, the resistance is 2, so 2 times 6/7, we get 12/7. And those two do add up to be what? 18/7, which is what they're supposed to add up to be. Make sense? All right, I'm going to stop that here for a minute. With